Hello, I hope you're well. My name is Adrian. I'm going to do a short video to try to explain you how I did this project. I deployed a React weather app application into AWS ECS. So I had to Dockerize this application and push it into the ECR registry, which is the container registry of AWS. And to build the infrastructure to host that application, I used Terraform. And I really enjoyed working with that, and I think it's a really cool project, and that allows you to use really powerful tools, not only AWS but Terraform to as infrastructure as code to quickly set up your infrastructure. So first of all, I'm going to show you this application. It's a simple React application that fetches the weather information from all around the world. So you just have to type the name of the city. It recognizes the country of that city automatically. It returns the weather information and also some extra information like if it's cloudy, if it's sunny, if it's rainy, etc. So we're going to have a look at this application. I used Yarn as like a node package manager. It's an alternative to npm package manager. Yarn is considered to be fast and reliable. That's why I use that. So we're just going to it's already running. Let me check my local host. No, it's not here. So local host. No, I think it's not running. So we are going to. So yes, this application has like a little feature that feeds the cache of the client with a little message. So if it's not connected, if it's not online, it's going to show this message. So we are going to run in a dev environment this application. We are going to use yarn start. Okay, so any city, we can say, for example, Montevideo. It's going to give us this small icon, the country, and the weather information. So this is in my local host. So first of all, to push that application into ECR, the AWS Container Registry, we Dockerized this application, not this one, this one. We used a multi-stage Docker file. So with two stages. First, to set up the node environment this application needs for running. But before building the Docker container, we have to use yarn build to generate the and compile the source code of that file, and then we can run the docker build command. But so as I was saying, it's a multi-stage Docker file. So the first stage is the node environment, and using yarn add, which is equivalent of the npm install. You probably see a lot of Docker containers that if you're going to set up a node environment, it's going to use the internally, it's going to run the npm install. But because I'm using yarn, I'm going to to use Docker yarn add. And the second stage of this Docker file is the Alpine distribution. And on that Alpine Linux distribution is going to run an Nginx web server. And in that web server is going to host the files of the source code and the files, the dependencies of my application. So here's the file. So this is yarn add. So if you are going to use npm, you would need to say npm install. So this is the node environment. This is the Nginx web server and the Alpine Linux distribution. The Alpine Linux distribution is much lighter and it's very common than the other Linux distribution, and Alpine is used for Docker basically. So yeah, and afterwards you would need to create your so here it is. Here is my app. Afterwards you would need to create your ECR repository and to push that image to your repository. So to build a container and push that image using Docker build, and then you use the tag option to to give it a name. I'm going to use WAP, which stands for weather application, and then so this is the those are the commands. And so to create the cluster in AWS, to create the repository in AWS, you can do it manually in AWS or use the AWS CLI and run some commands to create that cluster from your command line. Or you can use Terraform to do that. But I would recommend to, if you are going to use Terraform, to do it in a separate file than the Terraform file with all your TF files you are going to use to create all your infrastructure to host that application. Because if you want to, for example, if you want to destroy your infrastructure, if you're not going to use anymore that backend, you don't necessarily want to destroy and terminate this remote repository ECR, and especially if you are going to use a public repository, it's free until a certain limit of memory storage. But if you are going to use 5, 6, 7 images in a public AWS repository, you are not going to be charged. There is a always free usage for that. Okay, this is the second part of the video, is to generate the infrastructure in ECS to host that application. So I used for that user that is different from my root account, because this is part of security best practices. If you are going to do anything on your account, if you can do it with a additional user account, you should try to avoid to do that with the root account. So as you can see, I don't have anything here. I don't have resources running, just some security groups that I used in previous projects and some keepers. But I'm going to need to use one keeper. Keepers are necessary. They're very easy to create. You just go here and keepers. Keepers are necessary to log into your remote machines with the SSH protocol, which stands for Secure Shell. So if you are going to do anything using Terraform to provision resources from AWS through the Terraform CLI, using Terraform init, Terraform plan, Terraform apply, okay, Terraform needs to have to authenticate to your account. So there are different ways to do that. You can store in a secret TF file in your Terraform files. To do that, you can store your keepers. So the way I did it, I did this way. So there's my Terraform file. I used this file, and this thing here is just going to prompt me to provide myself my keys. So every time I need to create resources or destroy resource, the Terraform command line is going to prompt me my AWS access key and secret access key. Okay, so what I will need to create to host my React web application in ECS, I would need to create a load balancer listeners, target group, auto-scaling groups. Inside those auto-scaling groups, I would need to set the desired number of instances or virtual machines, the maximum amount of instances and the minimum amount of instances. So I'm just going to use two availability zones, and there's also a CloudWatch scale-up policy that would apply if needed. And I would need to set up a security groups that run in the instance level. Security groups work as security layers or firewalls, but I would need to set up those security groups need to allow inbound and outbound traffic, outbound traffic for fetching the weather information using asynchronous API calls, and of course inbound traffic so that anybody could access that web application. I would need to use this output Terraform file because I need this is the application load balancer DNS. So this is the domain name I need to access through my browser to this web application. I would need to set up AWS VPC, and those are the most important resources I would need to define in my Terraform file. Okay, so now we are going to run our Terraform commands, but just before you forget, it's a good idea when you are writing your files here, your TF files, you can use some templates that you can find in the official HashiCorp documentation. And that's a good idea because, for example, you get this kind of specification from, in this case, the AWS VPC, the public subnets, etc., and for example, the version, so you don't run into any technical potential issue. You need to have, it's a good idea to use the, the last versions. And for example, in this case, for the task definition, you can use like a JSON file. So you have to paste here the URI of your ECR image, and this JSON file. So you can find a template here, for example, in the official documentation. So this is a template of the ECS task definition. So you can add even more bells and whistles here. and this container definition is referenced here. When you say container definitions file, and this is this JSON file. Okay, so let's run the commands. So Terraform init is going to download the files and source code, the provider plugins, so we can communicate with the AWS provider. And now we are going to run the Terraform plan command. So it's going to create a Terraform state file. So this is the current state of the world of Terraform. And when I run plan command, so our Terraform engine is has already access to our AWS account, and it can compare the current state of our infrastructure with the desired state of the infrastructure. So here locally I have the desired state, what I want to do, and it compares both states, and afterwards it can with the Terraform apply command it can reach the desired state, creating the resources we want to deploy our web application. So I'm going to run Terraform plan. So this is the our cluster name. And then the name of our SSH key. So we can see here plan 23 resources to add. So before we use the apply command, let's check our things we have in our AWS account, our instances. So yeah, we don't have much. We just have some security groups that I have from previous projects, and those instances here are terminated already. They should disappear soon. So we don't have almost anything. Okay, now we're going to run Terraform apply. Again, our credentials, so the name of the cluster, ECS, Okay, so now after creating all the resources with the plan and the apply command, so in the end what you get as an output, you get this information. So you get here the ALB DNS. So just check this this domain name to see if your application works. So let's check first the resources in our AWS account. So let's refresh. We are in an incognito table. Here we can see some tasks, some pending services. So let's check in the EC2 instances to see our virtual machines running already in the cloud. So our application would be hosted in those instances. Let's check EC2 dashboards. So we can see all our resources here. We have some instances running already, 3 instances running, and so if we get a bad gateway 502, probably it's still the instances are still in creation, but we are going to check now. So our application is correctly running already in our in the AWS virtual machines. So let's test this. Let's try, for example, Sydney in Australia. So we have the information. Now we can see it's foggy. So yeah, that's it. I hope you enjoyed this walkthrough, and my repository will be published. Bye bye.